I know you're really into AI these days and how these large language models are evolving. And I'm sure you've seen some of the amazing things they can do with chain of thought prompting.
Yeah.
Getting AI to solve problems step by step like we do. It's pretty mind-blowing.
It really is. It's totally changed how we use LLMs.
Yeah.
Especially for those complex reasoning tasks.
Yeah. But there's a catch, right? All those reasoning steps,
Yeah.
all those steps come with a cost.
Right.
Literally.
Yeah.
We're talking about token usage here, which translates to computing power,
Yeah.
time, and, well, money.
Absolutely. There's always a trade-off between accuracy and efficiency with these models. The more steps the LLM takes, the more tokens it uses,
Yeah.
and the more expensive it gets.
Right. So how do we make these LLMs smarter, not just more powerful? That's what we're diving deep into today. We're looking at this paper from researchers at Nanjing University, Rutgers, and UMass Amherst. They're introducing a framework called TAIL. It stands for Token Budget Aware LLM Reasoning.
And along the way, they stumbled onto something really interesting. They found that simply limiting the LLM's token budget can actually backfire and lead to increased token usage.
Wait, what? That sounds totally counterintuitive. So giving the LLM less room to think could actually make it more verbose.
Yeah. It's a surprising phenomenon they observed. They're calling it token elasticity. It suggests that there's kind of a sweet spot, an optimal token budget for each task. And if you go below that, it can actually force the LLM to use more tokens to get the same information across.
Okay, my mind is officially blown. Can you give me like a concrete example of this token elasticity thing in action?
Sure. In the paper, they use this example problem about Peyton and her after-work activities. With a tight budget of only 10 tokens, the LLM ended up producing 157 output tokens. But when they gave it a more reasonable budget of 50 tokens, it only used 86 sender reels.
So it's like trying to cram this complex thought into a tiny little box. Sometimes you just need a little more space to express things clearly. But this raises a question for me. How do we determine that optimal budget in the first place?
Yeah.
It seems like finding that sweet spot is crucial for this whole TAIL thing to work.
Yeah, and that's precisely where TAIL comes in. It's all about finding that Goldilocks zone, that just right budget that balances accuracy and efficiency. It does this through two core phases: budget estimation and then prompt construction.
Okay, so TAIL first figures out how many tokens are likely needed for a given task. And then it uses that estimation to kind of guide the LLM's reasoning process. Makes sense. But how does it actually go about estimating that magical token budget?
Well, that's where things get really interesting. They explored 3 distinct methods for budget estimation, each with its own unique approach.
All right, I'm on the edge of my seat. Let's hear about these methods.
Okay, so the first one might surprise you. It's called the zero-shot estimator. Think about how you approach a math problem. You can often get a sense of how difficult and time-consuming it will be just by looking at it right.
Yeah, you sort of intuitively know whether it's going to be a quick calculation or something that will require pulling out the calculator and scratching your head for a while. But how do you translate that human intuition into something an AI can do?
Right. Well, that's the genius of the zero-shot estimator. They actually ask the LLM itself to estimate the token budget it needs. They prompt the LLM with the question and simply ask it to predict how many tokens it will take to generate a complete and accurate response.
So they're basically saying, hey, how much brain power will this take?
Exactly. And what's fascinating is that it actually works surprisingly well.
Wait a minute, hold on. Are you saying that the LLM can accurately predict how much thinking it will need to do? That seems almost too good to be true. What's the catch?
Well, it's a promising starting point. But it's not foolproof. Remember, this is still cutting-edge research. And there are limitations. But the fact that the LLM can even make a reasonable estimation of its own token needs, it's a significant finding in itself.
Okay, I'm starting to see why you called this fascinating, but I'm also a bit skeptical. Let's move on to the other methods. What about this regression estimator? What makes it different?
So this one takes a more meta approach. Instead of asking the LLM to estimate its own budget, they train a completely separate LLM to do the prediction.
Hold up. So they have an AI model that's learning to predict how much another AI model needs to think. This is getting really meta really fast.
It is, isn't it? It's like having an AI project manager, analyzing the complexity of a task and allocating the appropriate amount of thinking resources.
That's a great analogy. But this regression estimator, how does it actually work in practice? Do they feed it examples of previous LLM reasoning processes and the corresponding token usage?
That's a great question, and it's one that the researchers are still exploring in more depth. They haven't fully fleshed out the details of the regression estimator in this particular paper, but it's definitely a promising avenue for future research.
Okay. So we have this intriguing zero-shot approach where the LLM estimates its own budget, and this meta-regression estimator that's still a bit of a mystery. What about the third method, this token budget awareness internalization? What's that all about?
This third method is called token budget awareness internalization, and it's all about making the LLM inherently cost-conscious. Instead of imposing those external token limits, they're actually fine-tuning the model itself to produce concise responses naturally.
Oh, wow. So it's like they're building efficiency into the very DNA of the LLM
Yeah.
rather than setting up those external guardrails. But how do they actually achieve that?
Well, it involves carefully fine-tuning the model during its training process. By exposing the LLM to tons of examples of concise and efficient reasoning, they can kind of nudge it towards internalizing those patterns.
I see. That sounds incredibly elegant, but I imagine it's also quite challenging. I mean, how do you ensure the LLM doesn't become too concise and end up sacrificing accuracy? It's like finding that balance between brevity and clarity in human writing. You don't want to be so concise that your meaning gets lost.
Exactly. That's the real crux of the challenge here. And it's why this method requires such a deep understanding of the LLM's training dynamics. It's a very delicate balancing act.
For sure. Okay, so we have these three fascinating approaches to budget estimation. The LLM as its own estimator, the Meta AI project manager, and this inherent efficiency training. It's all very intriguing. But how does Tail actually put it all together to reduce token usage in practice?
Right. So once Tail has estimated a suitable budget, it incorporates that budget into the prompt that's given to the LLM. It's kind of like saying, hey, here's the problem, and trying to solve it using around this many tokens.
Okay. So it's not a strict limitation then. It's more of a suggestion or a guideline.
Exactly. It's about nudging the LLM towards efficient reasoning without imposing a rigid constraint.
I got it. And what kind of results did they see with this approach?
Well, the results are pretty impressive. They tested Tail on several benchmark datasets for mathematical reasoning, and it significantly reduced token usage, in some cases, by almost 70%.
Wow. That's a huge reduction. But did it come at the expense of accuracy? That's the real question.
Well, that's where it gets really interesting. On average, they only found a slight dip in accuracy, less than 5%. And in some cases, Tail actually performed even better than traditional co-Camper prompting, while using way fewer tokens.
Hold on. Are you saying that making the LLM more efficient sometimes actually boosted its accuracy? That seems counterintuitive.
Yeah, it does. But that's what their findings suggest. It's possible that by encouraging the LLM to be more concise, they inadvertently forced it to focus on the most critical parts of the reasoning process, which led to more accurate results.
That's incredible. But like with any cutting-edge research, I'm sure there are limitations. What are some of the caveats we need to keep in mind here?
Yeah, you're right. It's important to remember that this is all still a work in progress. They mainly focused on that zero-shot estimation method in this paper. The regression estimator and the internalized budget awareness still need a lot more exploration.
So there's still a lot to uncover. But even in its early stages, this Tail framework seems like a real game changer. It's showing that we can achieve both accuracy and efficiency in LLM reasoning, which is huge.
Absolutely. It's like a glimpse into a future where AI can be both super powerful and sustainable. Imagine complex AI reasoning without those massive computing costs. Or the energy consumption. That's the promise of Tail.
It's exciting to think about the possibilities. But let's step back for a second and consider the bigger picture. What does this all mean for someone like me, who's super intrigued by AI, but not necessarily a computer scientist?
Well, it means we're moving toward a world where AI is not only smarter, but also way more accessible. Tail shows us we can make these powerful LLMs much more efficient, which could have a ripple effect across tons of industries and applications.
So it's not just about theoretical advancements in computer science then. This has real-world implications.
For sure. And it raises some pretty profound questions about the future of AI. I mean, if we can teach LLMs to be more economical with their thinking, what other human-like skills might we be able to instill in them?
Wow. That's a great question. And it leads perfectly into something I've been thinking about. Let's explore some of those exciting possibilities and what they might mean for the future of AI. We've been talking about this Tail framework and how it's changing the game when it comes to LLM efficiency. It's amazing that we can actually make these powerful models more cost-effective, and in some cases, even boost their accuracy at the same time.
It really shows us that we're just scratching the surface of understanding how these LLMs work and how to really unlock their full potential.
Right. And you brought up the super interesting question earlier. about if we can teach LLMs to be more economical with their thinking, what other human-like skills could we instill in them?
Yeah, that's a big one. Think about it this way. Token efficiency in LLMs. It's kind of like mental effort for us humans. We don't want to overthink simple problems, right?
Of course not.
And when we're faced with a complex problem, we try to find the most efficient way to solve it.
We're always looking for shortcuts.
Exactly. We develop all these mental shortcuts and strategies to avoid getting bogged down in unnecessary details.
So if we can teach LLMs to do the same thing,
If we can translate those cognitive strategies into something they can understand and use, it could unlock incredible new possibilities.
so we're not just talking about making AI more cost-effective then. We're talking about making it think more like us.
Exactly. This could lead to AI that's better at understanding our intentions, adapting to new situations more quickly, and even coming up with more creative solutions to tough problems.
That's pretty mind-blowing when you think about it.
Right.
But wouldn't that require us to understand our own brains better first? I mean, we're still figuring that out ourselves.
That's a great point. And it highlights the need for more collaboration between AI researchers and cognitive scientists. By studying how humans think efficiently, we might just discover new algorithms and training methods that can make AI even more sophisticated.
It feels like we're moving towards a whole new era of AI, one where we're not just trying to replicate human intelligence, but actually trying to understand and enhance it.
I think you're absolutely right.
We've covered a lot of ground today, from the challenge of token costs to this token elasticity phenomenon, and of course, the innovative solutions from this TAIL framework. It's clear that there are some major breakthroughs on the horizon.
Absolutely. And this is just the beginning. As we keep exploring these concepts, we're bound to uncover even more fascinating insights into the nature of intelligence itself, both artificial and human.
Well, you've definitely given me a lot to think about. TAIL has shown us that we can make LLMs more efficient, and maybe even more intelligent, by teaching them to think more like we do. It's a powerful idea, and I have a feeling it's going to have a huge impact on the future of AI. Thanks for taking this deep dive with me.
It was my pleasure. Keep exploring.